Welcome everyone to today's third in our series of Chalk Talks. I'm Ann Goldman from Intel's Global Communications team. I'm joined today by Lisa Spelman, Corporate Vice President, General Manager, Intel Xeon Products. Hi, Lisa.
Hello.
And Ronak Singhal, Intel Senior Fellow focused on Xeon. Hi, Ronak. Now, before I hand it over to Lisa to get us underway, just a couple items about today's talk. As a reminder, the goal of these series and the series that we've done, so we've done the first two and this is our third, is to provide additional context around our products, product visions, the strategies, how we're approaching solving customer problems every day. So as we get ready to bring 4th Gen Intel Xeon Scalable processors to market, today's conversation will focus on context and thinking and approach around the product. And most importantly, we're going to leave lots of time for Q&A so you all can ask questions of Ronak and Lisa. As in the past and as in the previous two, all of today's information you are free to write about, you're free to share. Nothing is under embargo. And finally, please do submit questions via the chat, in the chat window. And as we get to the Q&A, I'll take the questions from the top for Lisa and Ronak to provide input on. Please do have your questions focused on the content that we're sharing, focused on today. And with that, I'm going to step off, hand it over to Lisa to get us underway.
Okay, thanks, Ann. Appreciate that. And hi, everyone. Welcome. It's really great to be here with you. We appreciate you guys joining us, and hopefully it'll be a good session, and we're looking forward to your feedback and questions at the end. So as you guys know, we're pretty excited about bringing Intel's 4th Gen Xeon processors to the market. Sapphire Rapids, it's here, and we're getting excited for it. But the big thing, and you guys have heard me talk about this before, is really getting it into the hands of our customers. We love to work in the lab about the things that we think the product can do, but every single time we bring something new to market, we find our customers and our partners and the ecosystem can do even more amazing things with the product, and they find ways to further advance literally the whole world working with their customers as well. So it's a really exciting time for us, and it's good to be able to finally share a lot of information and what we've been working on. In case you missed it, in the last couple of weeks, we've had a bunch of our customers start already talking about the way that they are either underway using 4th Gen or their plans to start delivering 4th Gen soon. At Google Cloud Next, actually, Google announced their C3 new machine series, and it's the first to feature not only their custom Intel IPU, but also their 4th Gen Intel Xeon Scalable processors. So they have that in private preview, and it was an exciting moment, not just for us, but for our engineering team as well, to see all that hard work and all the product process really coming to life. So I'm going to talk for just a minute about some of the context of the time that we're in, and then Ronak will have a chance to walk through some of the Xeon features and strategy and everything we've been working on. As you guys know, we're at this really unique, exciting time in history where the digitization of everything continues to just accelerate, and the pace and that complexity is something that we all need to work through. The demand for compute continues to grow. The ways in which that compute is satisfied continues to grow, and that pace of tech adoption is increasing every day. I've said this before, but there is no industry any longer that is untouched by the hands of technology. And I love to keep track of all of the ways in which the amount of data are growing. IDC recently had released some information from their global data sphere research about all of the data generated over the past 10 years. 40% of it was generated in the last 2 years. And this is something we've been watching and tracking for a while. And we know we're going to continue to see data generated at an even faster pace. We actually expect that it'll double in the next 5 years, but we've been surprised before. So if that happens in 4 years, 4.5, who knows, we'll have to keep an eye on it. But it just speaks to what that opportunity is, and frankly, some of the challenges that our customers are facing. At Intel, we have this strong, rich history of developing platform features and capabilities that both lead the industry forward, and we work very hard to solve real-world customer problems. delivering products and platforms that are architected to deliver the performance and the new capabilities the industry needs. Because again, it's not just that data is growing, but the shape of it and the way that customers want to utilize that for their business problems and challenges they're facing and their opportunity to better satisfy their customers continues to change and evolve. So we really do have to stay on top of it. Our customers, we feel like, are really seeking out the application performance that represents not just a pure benchmark, but what is their real operating environment, their most demanding workloads, and the ones that allow them to differentiate. And they're looking at this not just in the data center, but across their network, out at the edge, and that scale of where powerful compute, really capable compute is useful, continues to spread and grow. So for 4th Gen Xeon, we collaborated with our customers, with the ecosystem, with all of our partners to really understand their challenges, the shifts in their business environment, and what unique capabilities we felt we could bring to market to help address these challenges. To meet business challenges, we know our customers are requiring increased performance, definitely power efficient compute, strong security controls, and of course, attention to their overall operating cost. We'll talk a little bit more about each of these today. So for now, I'm going to hand it over to Ronak to share a little bit more about some of the thinking we had as we built the Xeon strategy and as we execute in this time of evolution for our customers.
Thank you, Lisa. So what I want to talk about today is to start with, what are the fundamentals behind what we think about as we're building each generation of Xeon, and obviously put it in the context of what we've done for Sapphire Rapids. And you'll hear me call it Sapphire Rapids. Lisa's better at calling it 4th Gen than I am. So I think all of you know Xeon is and has been the workhorse across a broad set of usages, whether it is on the AI side, traditional HPC, enterprise and databases, analytics, networking and storage. Those are all use cases that we care about and that we try to optimize for with each generation of Xeon. So it's an extremely broad set of use cases. And as Lisa talked about, the deployment model also matters in terms of what is the performance and power that our customers are looking for. It's not just about on-premise anymore, obviously. It's also about in the cloud and at the edge. So what are some of the market factors and challenges that we think about as we develop each of these generations of Xeon? So let me talk about that briefly. First of all, and I think Lisa touched on this already a little bit, is understanding the high value workloads. What are the workloads that move the business for our customers, and making sure we're aligned with what they need for their business success? The second is, how do we get ahead of the curve on where the high growth workloads are going to be? Where is the world moving to, and how do we make sure that we're providing the capability in Xeon today for where they're going to need that to be? Because one of the things that I think is becoming a greater trend is our customers using our Xeons for a longer and longer time. So if they're going to buy a Sapphire Rapids and use it for the next 5, 7, or 10 years, how do we make sure that they're able to use that well as their workloads evolve over that time frame? And then sustainability has obviously become a focus area in general across the world. And for many of our customers, the cost of power is critical to their overall TCO. So addressing the power efficiency of our CPUs is a first order factor now when we look at how we define what we're building. So if we look on the cloud side, one of the things that we are thinking about is, how do our customers measure performance? How do they look at and say, this is the product that I want, this is the product that I need? And I think that gets into a lot of the nuances about what is performance and how do people look at performance? Is it total throughput? Run an application across all the cores and see what your performance is. And that's an interesting performance metric, and it's useful for some things. But what we see from many of our cloud customers is the most important performance metric to them is not that total socket throughput, but in many cases, it's the performance per core, because that's what they're offering to their end customers. So how do we provide value, not just at a total throughput level, but also performance per core level? And then the other key thing we see from these customers is not just about the performance, but it's about that TCO metric, that total cost of ownership. And they're doing it not at the socket level, but at the rack level, or the data center level for that matter. right? How does this look like when they actually deploy it? And their TCO includes what is the acquisition cost of not just the CPU, but also the network, the storage, and so forth. And it's the lifetime operating cost. Back to that comment earlier about power. How much power you consume really drives that OpEx, that operating cost, and is a key factor for TCO. So really focusing more and more on power efficiency is becoming critical.
I think this is one of the things that we've seen change the most over the last, X number of years. And I, distinctly remember so much time spent with customers previously on acquisition costs.
Right.
But it's a much more sophisticated model. And we've actually had to grow our skills quite a bit in that space in understanding and building more with a thought and consciousness to the rack and that data center level that you were talking about, because you do make different design choices and trade-offs versus just thinking about a pure acquisition cost buying behavior.
Yep, exactly. The other thing is, with each generation of Xeon, typically one of the ways that we do add overall socket performance or throughput performance is by adding the number of cores. But like I just said, we have some customers that are looking for really focusing on that performance per core, some that are looking on that total throughput. So offering enough different options to them so that they can balance, where do I want to maximize performance per core, potentially with lower core count? Where do I want to maximize throughput with a higher core count? And so how do we manage the trade-offs between those performance metrics, between the overall socket throughput and the per core performance? That's one of the areas that, again, we spend a lot of time both internally looking at what our choices are, what our options are, how do we get flexibility, and then working directly with our customers to understand exactly what do they need from us. Anything on that you want to add, Lisa?
Yeah, I think I would add, like I was talking about there for a minute, it's just an area that we've actually both spent a lot of time on and more time over the past several years as we've watched this evolution happen. And I want to just tease a little bit that we will have some more news around performance and power for Sapphire to share at launch. And I think it'll be, some interesting new and compelling stuff. So I look forward to having the chance to share that with you a little bit, maybe just at a slightly later date than today. Okay, so I know you're going to talk us through some of the product specifics in a few minutes, but before we jump into those features and the architecture, I wanted to set a little bit of broad context around our strategy and approach for what we are bringing forward with 4th Gen Xeon. Thank you for the call out about my excellent brand adherence. So the Intel Xeon processor is and remains the foundation of the data center. And it's the most flexible and scalable architecture on the planet. It really can do anything. Xeon's ability to serve those network and edge requirements that I referred to earlier continues to grow. And you'll hear about the features that we're adding that enable those workloads to transition onto Xeon off of other compute options that exist in the market. So we're really working hard to continue to grow that TAM that we are able to address and those customer requirements that we're able to satisfy. Customers rely on Intel and the Xeon architecture to both support and fuel their unique business opportunities. So they have a lot of keep the business running work that needs to be done, but they're also advancing, again, that digitized business opportunity that sits in front of them. And this 4th gen of Intel Xeon, it's the most innovative and feature-rich Xeon processor we've ever brought to market. So it's exciting to have the opportunity to expose some of these features and get you all up to speed on what's coming a little bit ahead of that actual launch I was referring to. Okay, so now for some of those design principles and technologies that we're going to be talking about.
Thank you. I mean, it's super exciting to always talk about what we actually built into the product. So, this is a lot of fun to do. As we define Sapphire Rapids, our focus was really, like I said earlier, on the critical workloads, the features that our customers need to get that performance, to get that power efficiency, and to really have that longevity to scale with time. So how do we deliver the strongest value to our customers with a scalable platform? It's also, and you've heard us talk about this in the past, how do we maintain a system balance? How, when I increase the amount of compute that we have in the socket, both through having a stronger core, having more cores, having some of the new capabilities I'll talk about in a second, how do we make sure we also have the capability to feed that? And so talking about how we are improving the ability to move data into the processor is also critical. So the first thing is, in terms of our goals, is we want to provide performance, what we call out of the box. meaning a customer simply takes their workload and runs it on our new hardware and they get a performance benefit. That's the easiest thing for a customer to do. It has no friction for them to adopt our processor. And so that's what our ideal is. But what we recognize is that there are use cases where we can provide a step function improvement in either performance and or power efficiency for that matter. But to get that step function improvement can require software changes. It can be in the form of new instructions, so you have to recompile your code or use new libraries, things of that nature. But we believe that software modifications can pay off if we're giving enough value, if there's enough of a performance step function, if there's enough of an efficiency improvement. So the second thing that we look at is after the out of the box is what are those targeted improvements we can do to provide that step function and performance. And then when we're providing that step function and performance, there are multiple ways in which we can actually deliver that as part of our product. First is just embedding an accelerator essentially into the cores itself. And for a software perspective, you're using those just like you use any instructions that exist today in our architecture. So we've done that in the past, obviously, with AVX 512, which you're all familiar with. This provides the lowest latency, as well as the easiest path for software to use the capability. And it's a dedicated resource per core. So anybody running on the core knows that they have direct access to that capability. Now, we're also going to talk about some accelerators that we're adding on Sapphire Rapids that exist outside the core. The beauty of these is it allows the cores to do other work where you're really getting the value of the core while the accelerator is working in parallel. So you're able to actually do more with the overall system. And these accelerators tend to be able to do that very specific work that they're built for in a much more power efficient way than our general purpose cores can. So it's really a choice that we have on how do we design which accelerators do we use. And we're making sure that we focus on the accelerators that are addressing general compute use cases. We want those to be use cases that are broad in nature and of high value so that we're delivering performance, power, and cost savings through them. And if you compare this, there's multiple ways you can look at this. These accelerators you can compare to running a workload in the past directly on the CPU cores. And that's one way that we can provide performance uplift and an efficiency benefit. The other way is that for some of these use cases, customers today are using add-in cards, discrete cards to accelerate some of these functions because they're so high value to them. One of the things that we can now do with these accelerators on Sapphire Rapids is essentially remove the need for customers to use those add-in cards by reducing or eliminating completely the performance gap between what the Xeon can provide and what the discrete card can provide. And so that gives them a better TCO by eliminating one more component. It gives them a better power footprint by, again, removing one more component. So with Sapphire Rapids, we've done the most built-in acceleration of any CPU on the market, really to focus on the performance of those vital workloads. What I want to walk through now is just a brief mention of a couple of these brand new accelerators that we have, so you get an idea of what we're doing and why we did it. The first one is what we call our advanced matrix extensions, or AMX. AMX is integrated into each core, so this is an example of an accelerator that is part of every core that we have on the processor, and that is programmed with our standard x86 instructions. One of the things we've done with AMX is made sure that all of the key AI frameworks, all the open source frameworks that you know and love, are already updated to take advantage of AMX. So if you have your software that's able to use those libraries today, you just upgrade to the newest library and you get the benefit. And AMX is focused on matrix multiplication, which is the heart of most of the AI algorithms today. So we really believe that going after AI is critical. Then we have those accelerators that live outside the cores, like I was talking about earlier. The first one is our QAT, or Quick Assist technology. We've had QAT for multiple generations as an optional feature as part of our chipset, but now we're integrating QAT directly into our Xeon SoC. And QAT is focused on the acceleration of data compression and encryption, particularly for traffic coming over the network, but it can be used for other use cases as well. A second accelerator that we've added on Sapphire Rapids is our data streaming accelerator, or DSA. It's a high-performance data copy and transformation accelerator, which is targeted for optimizing streaming data movement and transformation operations, which are common across a variety of use cases. Storage, networking, we'll see it used in virtualization cases for accelerating VM migration as an example. Third, we have our dynamic load balancer, or DLB. This is a hardware managed set of queues. And the idea behind this is we have certain algorithms that are pipelined in the software level. So they're moving from core to core with the work that they have. And today's software manages how that work gets processed from one core and handed to the next core. With DLB, we move that software complexity into hardware. So it eliminates attacks on the developer. And then we are able to do it at a lower latency than software is able to do it. So where we see DLB really helping us are in algorithms like packet processing, again, on the networking side. And then finally, we have our Intel IAA accelerator, or in-memory analytics accelerator. Now, we just announced this a couple of weeks ago at Intel Innovation. So I want to recap what that is and actually give you a quick demo of how exciting IAA is. So IAA provides compression and decompression with very high throughput combined with analytic primitive functions. So functions that you typically see, for instance, in database operations like scanning and filtering. Those primitive operations will be used during a lot of different analytics query processing. So if you're able to use that and embed that into your database, you can see a good speed up. So let's take a look at the demo. So what we have here is RocksDB. RocksDB is an in-memory database workload that many of our customers run. It's an open source database that is fairly common in the industry today. On the left-hand side, you can see that we're running the analytics without the use of the accelerator. And on the right-hand side, we've optimized the use of the analytics to use our IAA accelerator. And you can see we're seeing a speed up of just about 2.1x with the advantage of IAA acceleration. And so this is part of the benefit that Sapphire Rapids can bring. And you can see, obviously, database usages are very critical and common to what we do with Xeon. The other good thing about IAA, it's not just about the raw performance, but we actually reduce the amount of memory bandwidth that's required to run these queries and the overall amount of memory that's required. And so you get these other ancillary benefits as part of IAA. I talked briefly about AI. I want to talk a little bit more about AI. I think, Lisa, we've had a lot of discussions about where are the future workloads going. And I think, we've made a big bet that AI is the future that's going to pervade every workload, whether it's a database workload, EDA workload for designing circuits, you name it, AI will pervade that. And so if you think of every workload containing AI, and we want every workload to run on Xeon, that means we really need to provide strong AI performance with Xeon. So what we've been doing for the last number of years is a significant investment on both the hardware side and the software side for AI. I talked about on the software side how we're optimizing and providing work into the open source libraries. On the hardware side, for the last couple of generations of Xeon, we've had our DL Boost technology with VNI and floating point 16 support, FP16. And with AMX, this is the next generation of what we are doing with AI acceleration. And in fact, it's, I think, our biggest step function ever in terms of the hardware capability. So we should have a second demo now that shows us the benefit that we're getting from AMX. What you can see in this demo is that we're providing about a 4.5x average performance gain just over this generation of Xeon versus the last generation. And that's across a broad set of deep learning workloads, BERT, DLRM, ResNet 50. So customers are able to meet even more aggressive SLAs with Xeon. And that 4.5x is just from the hardware improvement. There's also a set of software optimizations and algorithmic optimizations that can make that advantage even that much higher, using different data types and so forth. So we see the ability to use Xeon for AI continuing to grow because, you've heard us talk about this before. The workhorse for inference in the data center today is Xeon. And as we continue to add these capabilities, we believe it'll continue to be that.
You know, I think back to you, me, Sailesh, and that decision to put Vian and I into Xeon in Cascade Lake, and just the way in which our capabilities, our sophistication, our knowledge in that space has grown. And really, the hardware has advanced, but our software work has advanced tremendously as well. AMX might be the most demoed pre-launch feature we've ever done in my history of Xeon, but I think that just gives an indication for how excited we are about it. We're also seeing some great results with training. So it's a little too soon to share some of those details, but I encourage you all to check out the results when they're available. And think about, in your head, training smaller models like BERT or DLRM over lunch instead of overnight. So that's the scale we're talking about of improvements.
So the one last thing I want to briefly talk about is on the high performance computing side. Because what we see is, even if we do a great job increasing the number of cores, making the cores more powerful, is that our performance is not limited by that, but it's limited by the ability to feed the cores. And that the amount of memory bandwidth that you can feed them is really what drives your performance. So we do have now with Sapphire Rapids a new version of Sapphire Rapids that includes high bandwidth memory, or HBM, directly embedded in the package. And this delivers much higher memory bandwidth than the standard Sapphire Rapids. And you see that for some key HPC and AI workloads getting a significant performance benefit from the HBM. And in fact, we'll have customers that only use the HBM as their main memory and won't have DDR memory. So that also is a cost savings to them. All right, so now I've talked a lot about the capabilities inside the SoC itself. I want to talk briefly about some of the platform capabilities. Again, how are we connecting this processor with all of this capability, all these features to the outside world, and making sure we're able to feed it? And in fact, this is probably the biggest platform transition I've ever seen us make in the 25 years I've been here. I don't know, Lisa, if you can think of something bigger, but we have three major new technologies on the platform. We have DDR5 for memory, we have PCIe Gen 5 on the I/O side, and then the introduction of CXL 1.1, which we think will be a seminal moment in the data center. So DDR5 is all about how do I get to higher memory bandwidth than we can get with DDR4, because as we keep talking about, as I increase the compute of the socket, I need to be able to feed that compute. And we work extremely closely with our memory vendors and our customers to make these memory transitions, because new memory technologies are not easy, and they take a lot of work for us to get to the point where they're stable enough and easy enough for our customers to take advantage of. Next, we have PCIe Gen 5. So again, higher bandwidth for I/O devices that require that. And we do have a number of PCIe Gen 5 devices that already exist into the market or will be coming out soon. So again, when we talk about the longevity that we provide with Xeon, how do we make sure we have that with our I/O interfaces? Then the last one that I want to talk about just really briefly is CXL, or Compute Express Link. If you go back, a couple of years, Lisa, when we were doing CXL, before we even called it CXL, we had a technology internally. What was the name? I don't remember.
Yeah, I'm not adding one more code name to this, but there was a code name, you better believe it. But it was an exciting time, and we invented it, and we had this big decision to make. What are we going to do? Is it going to be Intel's alone, or are we opening it up to the ecosystem, to the world?
Yeah, and we obviously went down the route to say, hey, we're going to give this technology to the consortium. We're going to build a consortium with our partners, our customers, and in some case, our competitors, because we believe that that's the right thing to do to build a rich ecosystem of use cases and devices. And what we're seeing is essentially an explosion of use cases coming from both customers and from startups and other partners, particularly about using CXL to expand memory for memory capacity and memory bandwidth. And Sapphire Rapids will really be the first step on that journey down the CXL path. Lastly, we've only talked about the accelerators and the platform enhancements. We have so many other good things in Sapphire Rapids, and we just don't have the time today to talk all about them. We'll talk obviously more about them over the coming weeks and months. Some of them I think you're aware of. We have the enhanced core that we use. So it's the latest P core. It's optimized for servers. It includes the AMX acceleration we just talked about. We also have acceleration for 5G built in directly into those cores as well. And some of the innovations we have are on the way we build the products. How do we use our innovative packaging technology? The way we build Sapphire Rapids is using what we call our EMIB, or embedded bridge technology. And really that's taking advantage of a lot of the packaging enhancements that we have. So we're really working closely with our customers and with our partners, getting their feedback and making sure that what we're building with Sapphire Rapids is what they want, what they need, and something that they are excited about. And at least based on the conversations I've had with them, I think they're excited. I mean, what do you think?
They're excited. They're already announcing it. We haven't even launched. So
Yeah.
they're running it in their data centers. So thank you, Ronak. And as we think about what matters most to our customers, and we'll wrap up quick here, but we really obviously look at performance, which we've just talked about for a long time. Beyond performance, we work very hard to use our IDM advantage to our customers' benefit. So the flexibility the factory network gives and provides us allows us to be the most reliable supplier for our customers. And that has been so important over these last couple of years as the world has gone through such dramatic shifts and changes. We invest in security and reliability, not traditionally measured by performance benchmarks, but critical to data center customers and their customers' data. Scalability is incredibly important as well. Solutions built on top of Xeon offer the most choice, the most flexibility, no matter what that deployment path is, from your 1 socket up to your 8 socket and beyond. And then that just ability to deliver to those most demanding applications. Quality is obviously job number 1. So our future Xeon families will continue to push all of these boundaries that we've talked about today. We have no plans to stop innovating, making big calls, adding new exciting features and capabilities. And our customer-driven roadmap will show you by delivering this scalable architecture that provides so much benefit to all of these world class of workloads.